Hi all, in this video I will going to discuss persistence in LangGraph. Let's see why we need persistence in our LangGraph application. When you build up complex AI chatbot to agentic AI system, memory is more important. Let's discuss what are the difficulties we are facing without memory in our application. Let's assume we are deploying our application into productions, but we are not maintaining the memory. Once user interact with our application, during the conversation, he might ask the previous question again. But our application couldn't able to provide the proper answer for that because we are not maintaining the previous chat history. Another scenario, user might ask the same question again and again, but our application provide the hallucination response for each and every time because we are not maintaining the previous conversation. Another scenario, during the conversation, let's assume our app get crashed because of some network issue or some issue. Assume app get crashed, then again user might reopen the application and he can see the new conversation instead of the previous chat history. Why? Because we are not maintain the memory. In that case, after the app crash, all the previous data get deleted. Because of these issues, user might have bad experience on our application, so he will not further going to interest in our application. That will directly impact in our application growth. So to overcome these issues, we need to set up memory in our LangGraph application. So let's see during the example how we're going to set up memory in our LangGraph application. To set up the memory in LangGraph, we need thread ID and the checkpoint. Thread ID is nothing about unique ID for each session, and the checkpointer is a snapshot of the state. Once after execute the every step, so this checkpointer will help to store the snapshot of the state in the database. Let's say if we use same thread ID, it will get update the same context. If we have new thread ID, it will create the new record. For here you can see two graph. One is having memory, other one is without memory. So you can see the without memory one. Once after execute node 2, the state get destroyed. So it will not maintain the memory. So you can see the with memory one. So once after execute the node 2, the state will store in the database. So in that case, if user asks again the same question, so application can repair the previous conversation and application can provide the proper answer for the question. Hope you have clear on this. Okay, we will jump into the live example. So over there we will discuss more on this. Here I will going to implement a small chat application without memory with help of LLM. So let's see what are the issue we can see in this example. First we need to import all the libraries. Here I have added all the libraries. Then we need to initiate our LLM. So here I use Open API. Here I have added the Open API. Then we need to compile it. Then I need to create the state. Okay, so here I have added the state, and here I have created the message list, and also here you can see I have added the add message reducer here. So and because why we need to define like this, we have to keep our all message as a list. So if we are not use this reducer, so each and every time if we added this message, it will get replaced. So that's because of that we need to add this reducer. So in that case it will maintain all the conversation from 0 to n. Then we need to define our node. Only here I have one node, so that is LLM node. I will add LLM node here. Then we need to define our graph. So let's define our graph. So need to compile it. Let's compile this one. App. Let's compile it. Okay, this is simple straight graph. We are having only one node. You can see we need to define that node. You can see here I have defined the node, then start point. So we need to define the entry point. So here we have only one node. I define the same LLM node as entry point, and then we have to define the end node. So here is the same LLM node we can define as the end node. So then need to compile it. Then we'll see when we'll see the output. So we'll run this example and see how this work. Then I will find hi. You can see, hello, how can you can see this is the bot response. Then I will type here, my name is, then we will see the response. So then bot is reply, hello Aruna, how can I assist you today? Then I will ask one question, what is capital of India? Then I asked one question, what's the capital of India? Then bot replied, the capital of India is New Delhi. So then I will ask my name again. So here, so you can see here previously I mentioned my name. Then I will check from the chatbot again, what is my name? Then see the response. You can see that chatbot provide I don't have access to personal data. So it's mean that the application couldn't able to provide the proper answer because I already provided my name earlier, but later part of the conversation, if I asked same question, the application couldn't able to provide the proper answer. So that's where the problem we have without having memory. Let's see our in the next application or let's see in the next example. So we will going to add memory here, then see what is the response we are having with same question. We'll exit here, we'll clear this one. Okay, so now we will going to add memory here. First we need to add the memory saver here. So here, before compiling the graph, so we need to add a checkpointer. So this is how we need to add checkpoint here. So we need to add checkpointer. You can see I have added the checkpointer. Then we need to add the thread for our conversation. So here we'll add thread id. So here we need to add the unique thread id for each conversation. So for this conversation, here I have added live chat session as a thread id. So here we need to compile this and this one, and we'll see what is the conversation. Let's chat with now. Let's see what's the output here. First I will add same conversation with this two. First I will have, okay, we need to add the thread here, so we need to configure the config. You can see we have got one issue here. So because we forget to add the configuration here. So we have added the configuration. So let's compile now. Then we will ask same question. Hi. So bot is replying hi again. What's your mind? My name is okay, I replied my name is Aruna. Nice to meet you, Aruna. Bot replies, nice to meet you, Aruna. How can I help you today? Then I will ask same question. What is the capital of India? Then bot replies, the capital of India is New Delhi. Then we will ask same question. So again, what is my name? You can see your name is Aruna. How can I assist you further? So now you can see. So previously you saw, right? Previously that application couldn't able to figure it out my name. If I ask same question again and again, without memory example, we couldn't able to get the proper answer. But with memory, you can see I have previously I mentioned my name, then I ask my name. So then a bot is provide the proper answer. Your name is Aruna. So that's how this application work with memory and without memory. We will get exit here. We need to type exit. Hope you have clear on this. In my next video, we are going to build a small chat application like this. Here you can see we have new chat, and also we have a previous conversation. So let's click new chat. We'll add hi here. So here you can see it's we are getting the response from the assistant. So then here you can have your all conversation, so you can continue from where we left off earlier. Okay, we will discuss this in our next video. So for now we are going to end this. Thanks all.